and welcome to chapter 3. And today we're going to talk about the structure of crystalline solids. So today what we're going to look at, we're going to see how the spots in a diffraction pattern are produced. And second, we're going to see why we study the structure of crystalline solids. And we're going to see the learning objective, why we learn crystalline solids. And also we're going to see the fundamental concepts like crystalline, crystal structures, and lattice. And after that, we're going to see the unit cells, and we're going to look at metallic crystal structures and diagrams like the FCC, the BCC, and the HCP, which is the face-centered cubic, body-centered cubic, and hexagonal closed path. Then we're going to see the density computation. In density computation, we're going to see polymorphism and allotropy. Like, we're going to look at some examples like carbon, iron, materials of importance, and crystal systems. So we have 7 crystal systems, and we're going to see them in terms of their axial angles and the unit cells. So you might ask why we study crystalline structures in solid material. We study the crystalline structures in solid materials because the structure help us or dictate the properties of these materials. So for example, we can use what we call the X-ray diffraction to determine the structures of a material. For example, if we say here, if we have a pattern, we have, let's say, an X-ray diffraction, an X-ray source here. Let's say this is the X-ray source. X-ray source. So in this X-ray source, let's say it projects these incident beams. In the incident beams, we can have a lead plate. A lead plate here. This lead plate will block all the incident beams that are coming from the X-ray source. So however, we can make a small hole here. This small hole will allow the X-ray to go through. So this small hole, this X-ray will go through, but these ones will not go through. All this will stop here, all this will stop here, but this one will go through. So now, if we say this is the lead plate, this is lead plate, we say PB. Okay, but here we can put a magnesium, a pure magnesium material. This pure magnesium material should be a single crystal structure because we want to determine the crystal structure of magnesium. So what we can do, we can have a magnesium material here. Oh, this is not good. Let's see this one. Let's say this is a magnesium single crystal structure. So this is the magnesium, Mg for magnesium crystal structure. So this is the magnesium crystal structure. However, if we penetrate this is the incident beam. Remember, this is going through the lead, and we can call this the incident beam. The incident beam. So if this incident beam go through this material, what will happen? You will realize that this beam will be scattered again. Something like this will be scattered all over. And now, what will happen if we have a detector, a photo detector, which we can call the Lowy photo detector here, then what happens is that you can see some dots. You can see so many dots here. This we can call this the Lowy photograph. Lowy photograph. Lowy photograph. This is the Lowy photograph. So what we can see, you can see this one will pass through this material, and sometimes you can see a big dot here. Okay, this is the refracted beams. This one we can see this is the refracted beams. Okay, this is the refracted beams. So however, you can see some patterns. So what we're going to do, we're going to take this photograph, this Lowy photograph, we can make it bigger. So this particular one, we can take it and make it bigger. So this dot is here. This is the bigger dot. Okay, this, and we can have other dots like this. So now what we're going to do is that with this photograph we can be able to determine the structure of this material. So looking at this pattern, so mathematically what we're going to do is that we're going to look at this pattern, enable us to determine the structure of this material. For example, for magnesium, which is it have a crystal structure that is HCP. HCP meaning hexagonal closed packed crystal structure. So what do we mean by that? So these have a hexagonal shape, meaning that it has something like this. Because now you cannot see it this way, I can just draw it here, draw it here, draw it here, draw it here, draw it here. So it can have something like this. Okay, and then the same thing, you can draw this crystal structure again. So this is the crystal structure. So the only way we can able to determine this crystal structure is by studying these patterns mathematically. So understanding these patterns will enable us to determine the crystal structures of materials. So we can use different crystal structures. For example, we can use gold, we can use diamond, we can use silver. Then we can able to determine the crystal structures. So that brings us to this first point of how we determine the spot and patterns that are produced. So next, we're going to look at why we study the crystal structures. So look out for my next video wherein I can explain this all in details. Thank you very much.